In this video, we're having a look at two different graphs. It's probably going to be split into two so that we can keep it shorter, but we're looking at y squared equals x and y equals the square root of x. And I know these might sound like they represent the same graph, but it's to do with the domain and being real numbers. They actually represent two different kinds of graph. But both of them are, in effect, a rotated parabola. Again, we're doing this because we want to expand our knowledge on types of graphs, and our success criteria is just that we want to be able to sketch both of these graphs. So just like we did in the last video, we want to have a think about a table of values for y squared equals x. So obviously we have our x values, and we're just sort of taking the square root of those values and we're getting the plus or minus in the y. Because either way, if we square a negative, we're going to get a positive. Same with the positives. So as you can see, it ends up as a parabola that's just flipped over on its side like that. This has technically been reflected around the line y equals x, so the linear equation, just like that. But the vertex is going to stay at 0, 0, so what would have been the minimum of our parabola. And our axis of symmetry, instead of being the y-axis, is now the x-axis. Again, all our previous transformation rules apply to this. So the general form of this graph becomes y minus k squared equals a squared times x minus h. Yeah, because we would have y squared, and we translate y using k, and we would have a times x, but we've got x minus h, and the a is going to become squared just as a process of the transformation. The vertex of it, so the turning point, which is on the side this time, is still going to be at the point hk, and the axis of symmetry is when the value of y is equal to k. It's important to note that this is not a function, because if we do a vertical line test, we get 2 points of intersection. So it's not a function, it's just a relation, which means we cannot use the f of x notation because that is only reserved for function. Now, just like with any other sketch we're doing, when we want to sketch it, we need to find important points that we're pointing out. So in this case, those are going to be the vertex and any intercepts. We know our vertex is going to be at hk. And in this instance, our value of h is going to be -3, because this is going to be x minus h. So -3, and then 4, because this is y minus k. So we know our vertex is sort of 1, 2, 3, 1, 2, 3, 4. Let's put it about there. That would be our vertex. And we know that it's going to look like a parabola, so it's going to sort of look like that. Well, not quite. More like that. Pretend it actually goes through that point. Now we need to know the values of these 3 points here. And obviously, it's not going to be to scale in the end, but that's okay. We're just sketching to give an idea. So our intercepts, let's start with our y-intercept. So when x is 0, we get y minus 4 squared equals 3. Take the square root of both sides. We get plus or minus root 3. So y is going to be 4 plus or minus root 3. So that's going to be a little bit more than 2, a little bit less than 2. So 4 plus or minus about 2, just to give you an idea when you're sketching. But we'd say this is going to be 4 plus root 3. That's going to be 4 minus root 3. And then our y-intercept. So then we want to do our x-intercept. So when y is 0, we would have 0 minus 4, so -4 squared is going to be 16 equals x plus 3. Take 3 away from both sides. X is going to be the point 13. So obviously not to scale, but we get the idea. That's that sketch. For example B here, we can see that it's not in that correct y minus k squared equals a squared times x minus h form. We've got y squared, 2y, 2x, 3, like we've got weird things happening all over the place. The way to convert that graph so that it's in the correct form and make it easy to sketch is actually going to be by completing the square. So if you're not sure how to complete the square, you don't remember it, go back to your work on standard parabolas, make sure you know how to do that, but we'll do that here. So we're going to have y squared plus 2y. We're going to add 1 to each side, so half of the b term squared, so 1 squared is just 1. Adding it over here as well, we get 2x plus 4. This side now factorizes to y plus 1 squared, and we can take out a common factor of 2 on this side to become x plus 2. So now you can see it is exactly in that form that we want. Our vertex is going to be at -2, -1, because we've got h and k. And then we just need to work out our intercepts. So because we know that the vertex is going to be down here somewhere, we know because of the shape, we're going to have 2 y-intercepts and an x-intercept. So let's work on those y-intercepts first. When x is 0, so we have y plus 1 squared equals 2 times 0 plus 2, so just 4. Y plus 1 is going to equal plus or minus 2. So y equals -1 plus minus 2, which gives us -1 plus 2 would be 1, -1 minus 2, -3. So we know we've got, if this is the point, what did we say? This was -2 and -1. So let's put it there. So that's 1, 2. So we've got -1, 2, 3, +1. Gives us a sort of good frame of reference to sketch from. Whoops. Obviously, this is going to be easier when you're doing it on paper. And then we just need to know what that point on our x-axis is. So when y is 0, we get 1 squared, effectively. So it's just 1 equals 2x plus 4. Take 4 away from both sides. -3 equals 2x. So -3 on 2 is our value of x there. About 1.5. So we've got it in roughly the right place. And there's your sketch.